Welcome back, and today we are finally covering camera movement. But first, I want you to see why we need camera movement in a video game. So back to our code example. From the last video, we made all the orbs move diagonally using vectors, and we're going to undo some of that because it's really not necessary. That's just to learn about vectors. But as you can see, the player does not follow or does not stay fixed in the screen. The player can move off the screen. And that's going to be a big problem. We want the camera to stay fixed on the player the entire time so that the player stays in the middle of the screen here and everything will move around it. And here's how that works in video games. Imagine I have a player right here, and then I have a bunch of other random objects in the scene like this. The way a camera movement works is the player stays still and just everything else moves opposite of the player's movement. So let's say the player is wanting to move towards these orbs to eat it. Well, as of now, the player would just move like this, but that means he could move off screen. We want the player to stay fixed on the screen here, and instead, we can achieve the same visual effect of the player moving right by having everything else move to the left towards the player. Because in both of these cases, the distance between the player and the orbs decreases, and by having the orbs move to the left, it looks like the player is moving to the right and is going to eat them. And that's what we're going to do with the camera class that we're going to make today. We want the camera to force the player to stay in the middle of the screen the entire time, but everything else will move around the player to reflect his movement. So if the player moves up, all the orbs are going to move down. If the player moves to the left, all the orbs are going to move to the right, like this. But how do we actually achieve this? Well, this is where you get into more math stuff. I'm going to redraw the player over here. That's why I have my graph here. So say that the player is currently in the middle of the screen, which means that his position is just 0, 0. And say there's an orb over here on the right, and it is 10 blocks or 10 units to the right. So the orb's position is 10, 0. Now the player moves to the right so that it can touch the orb and get the points from it. So the player's new position is 5, 0. But we're not actually going to draw the player at 5, 0. We're going to keep the player drawing at 0, 0, and instead we're going to move this orb using this formula here. We're going to, this position here, we are not going to change. The orb is still going to be at 10, 0, but we're going to give him a new set of positions that will be his drawing position. So this is his game position, but his drawing position will be somewhere else. And here's how you calculate the drawing position. I'm going to call it draw x for where on the x-axis the orb's going to draw. And this is just equal to the x position, which is the 10, minus the camera's x position, like this. And then the drawing y position is equal to the y position of the orb minus the camera's y position. So let's see how this plays out. So 10, 0 is the orb's actual position. The orb is not changing its position, but we're going to change where it draws because the player just moved over to the right a little bit, and we want to reflect this. So the drawn position for this orb is going to be, well, his old x was 10, and the camera, which is going to be on the player, is at 5, 0. Not this position, the player moved. 5, 0. So we just left with 10 minus 5. The drawing x is 5. And now the y doesn't change at all. We have his old y, his actual y position 0, minus the camera's y, which is 0, so we're left with 0. So the drawing y position is 0. So, to summarize, the orb's actual position is 10, 0, but when we apply this math, we can calculate a drawing position for where we want the orb to look like it is. And 5, 0 is halfway. It's right in the middle, and that would make sense. The player just moved 5 units to the right. So that's going to make, if we tell the game to draw at 5, 0, it's going to make it look like the player moved to the right by moving the orb to the left. And this math here is the same math we're going to use for everything. The player, all the other orbs, everything in the game that's drawn is going to use this math. It's going to have its real position, but then it's going to have its drawing position that's just based off of the camera. And also notice, if we use the same math on the player always draws a 0, 0. Because if the player tries to move 5, 0, well, 5, 0 is his real position, but his drawing position is 0, 0 because 5 minus 5, the camera's on the same spot as the player. 5 minus 5 is 0, 0 minus 0 is 0. So this is the math of how our camera's going to work, and you can rewatch this portion of the video several times, or as much as you need. It took me a while to grasp when I first learned this. But for now, I'm going to go back to the project, and I'm going to create a camera class. So I'm going to right-click on my project name, New Python File, camera.py. And this is a really basic class, because really the camera's not doing anything other than just storing its own position. So I'm going to have a class camera, and then I'm going to create the constructor for that new class. And for the constructor, we'll give it a starting X and a starting Y position. And the camera, we're never going to draw, and we're never going to check collision with it, so we don't need a Pygame rectangle. We don't need any of that, so I'm just going to give it two private variables. Self.x is equal to x, self.y is equal to y. So the camera only has two variables, x and y, and that's all this class is going to store. It will have two other functions, though. We want to make sure that the camera is always in the same spot as the player, because if the player ever moves to a new spot, but we forget to update where the camera is, and the camera still thinks it's somewhere else where the player is not, then this math isn't going to work correctly. So every single frame in the update function, we're going to update its position so that every single frame, its position will be reset to the players. So here we're just going to take the player X and the player Y, and all we're going to do is make sure that the camera's X is the same as player X, and then make sure the camera's Y is the same as player Y. We're going to call this function every single frame so that the camera never leaves the player, and the math will work out perfectly. And for now, that's all we need for the camera. I'm going to go back to main game. And this is why I like this class, because this class is going to have most of the, going to do most of the heavy lifting, I think is how I put it in the first video. We're going to give the main game the camera. So from camera, import camera, and I'll create the camera right here. Self.camera is equal to camera, and then the two arguments would just be, I'm just going to go ahead and hard code it. That's not great. I could have a starting X and Y for the player and the camera. I may as well do that. Let me do that. Player, I'm going to define two constants that will tell us where the player starts out in the game, so that I'm not just hard coding zeros here and zeros here. So player start X is equal to 0. Player start Y is equal to 0. And we're going to use these for the camera and the player here. This isn't really necessary, but it makes your code more readable. There you go. So now we have a camera. Now let's update that camera so that the camera always follows the player. So inside the main game's update function, the big update function that calls all the little update functions, we'll call the camera update. So self.camera.update, and it wants a new player X and a new player Y. We're just going to call this every frame, even if the player didn't move. It doesn't matter. An extra reset won't hurt at all. So self.player.rect.x, self.player.rect.y. And just to make sure I didn't make any mistakes, I'm going to go ahead and run this. And no mistakes. Now the camera doesn't do anything yet because we didn't actually calculate any of the drawing positions. Okay, so the next thing we're going to do is we're going to go back into camera class and we're going to add that calculation. We're going to create the function that will, using this formula, calculate the new drawing X and drawing Y of any given object. And I'm not going to call it calculate draw position because the technical term for what we're doing is translate. When you take a bunch of objects and you shift them based off of certain variables, we're really just translating them. And that's another math term, and I'd prefer to use it for the name of the function. All the translate function is going to do is it's going to calculate those drawing positions. So we're going to take an X and a Y, and it's going to give back a X and a Y that are the drawing positions. So we're going to apply that formula. So we're just going to return a list with an X and a Y, or it actually could be a tuple. We're just going to return a tuple, but we're going to return the X minus self.x because that is the formula right here. The drawing X is the position of the object minus the camera X. So the X minus the self.x, that's going to be one element, and then the Y will be Y minus self.y. So this function here will take an X and a Y, and it's going to give back the drawing position for that object. And now all we need to do is have the orb and the player use these. So we'll start with the orb. The orb has a draw function, but it doesn't use drawing coordinates. It uses its actual coordinates. We don't want to use the actual coordinates. We want to use the drawing coordinates. So we need the camera. So as a parameter, I'm going to pass in the camera, and window.blit is that function I taught a while ago that will draw a texture. And its second argument is position, but we're going to get rid of this. We don't want to use the actual position. We want to use its drawing position that we calculated. So we're going to pass in the texture for the first part of window.blit, and then we're going to say camera.translate, and then in here I'm going to put self.rect.x, self.rect.y. And this function will give back the correct drawing coordinates. Now we need to do the same thing with player. So let me open up the player file. And the player also has a draw function. We're going to pass the camera in. And we're going to do the exact same thing. Replace the actual position with the drawing position. Camera.translate self.rect.x, self.rect.y. And now, to finalize this change, I'm going to go to main.game.py, and we need to pass in the cameras in the areas we ask for them. So under render, the player draw function now wants the camera, so I'm going to put self.camera. And then the orbs also require a camera, self.camera. And this should now work with our correct camera movement. And look at that. Our player stays in one spot, and as I move to the left, everything moves to the right. And as I go up, everything moves down. I go down, everything moves up. And this is great because now we can actually follow those orbs off screen, and we no longer have a screen limit. This is most of the work for the camera class right here. The only thing is the player is drawing in the corner. That is correct. I was expecting that. The reason is because, like I've mentioned a few times, this is not the same as in Pi Game. In Pi Game, the 0, 0 is not in the middle, it's actually in the corner of the screen. This corner of the screen is 0, 0 for the game. So what we're going to do is we're going to modify our formula a little bit. So I'm going to clear some of the screen here. That will be enough. And I'm going to redraw a window. So now we're going to do the actual game example. The math works fine. It puts the player at 0, 0, and the player is forced to stay at 0, 0. But we should add, so he's not in the corner, what we should do is we should add half the screen width and half the screen height, which will put the player almost in the middle of the screen. And I say almost because the player's position, the player's registered position is right here in this corner. So if we add, let me go ahead and add that here, plus screen width. I'm running out of room, so I'm just going to say SW divided by 2. If we add half the screen width, and then we add half the screen height, then that would put this corner position for the player in the very middle of the screen. But we want the whole player to be in the middle of the screen, not just the corner. So I'm going to take back half the width of the player and take back half of the height of the window. So I'm going to add these to our formula now. Most of our formula, this part does most of the work, but we do need to make the player in the middle. Minus player width divided by 2 minus player width divided by, or player height divided by 2. It doesn't really matter. Our player is the same size, width, and height, but we want to be exact in case we ever do change that. And this is the whole formula. Now again, to explain that last part, our player, if we just left it at this part here, the player would be stuck in the corner. And we want the player to be in the middle of the screen. So we're going to cut the screen in half, and we're going to move the player. We're going to move the player to half of the screen width, which is right here. And then we're going to cut the screen in half this way again. And we'll move the player to half of the screen height right here. But unfortunately, that is only the player's corner position, not the actual player middle. So right now, the corner is in the middle of the screen. We're going to take back half of the player width so that he goes right here, and half of the player height so he goes right here. And I hope that wasn't confusing, but when we see it play out in the code, it will all work out. So I'm just going to go to the camera. I'm going to stop the game. I'm going to go to the camera, and I'm going to make those adjustments. Oh, we do need the player width and height. However, the orb is calling the camera, and I don't want to also have to put the player width and height in here. What I'm going to do is the camera, I'm going to give it more private variables, self.playerWidth, and I'm going to add a player width, because we need to have this information to do the completed formula here. But the camera doesn't have that information. It doesn't know how wide or tall the player is. It doesn't know how wide or tall the screen is. So actually, let's make this easy. Player dims, we'll just pass it in as both. So now the camera has the player dimensions, and next it needs the window dimensions. Sorry, my coding is all out of order. I'm doing this in a kind of weird way, but we just added 2 parameters, the player dimensions and the window dimensions, so that the camera actually has this information to work with. So now, in our translate function, where we calculate the drawing position, I can say self the X of what we're drawing minus the camera X, but we're going to add WinDims 0, which is going to be the window width divided by 2. And we're going to take away the player width, player dims divided by 2. Oh, and I need a 0 here. These are going to be tuples. That's why I'm indexing them here. It's going to be an x and a y, or sorry, a width and a height. It's going to be tuple with 2 elements, so that's why I need the index. And I'm going to add a line here. Y minus self.y, that's what we originally had. Add back half the height. Take away half of the player height. Like that. That is the whole completed formula, and that should put the player perfectly in the middle of the screen. Let's just give the player this new information that it asks for in the main game. We create the camera, or sorry, give the camera the information. So here we're going to pass in the player dimensions, which we have. Do we have the player dimensions? How is the player start width, start height? So I'm going to pass in a tuple, start width, start height. I should change that to player start width, start height, but I won't do that now. Another tuple, which we already made up here, WinDims, self.WinDims. And like that, we should now have the player in the middle. WinDims is not defined, so let me go over camera. See what I did. I forgot self, as I normally do. I'm going to put self here and self here. And now look at this. That is the end of the tutorial. The player is being drawn perfectly in the middle of the screen. We have good camera movement. We have unlimited space to work with now. And this is a big step up for the Slither.io game. So thank you for watching. This was a kind of long one. We got one more big one as far as I know, but stick with it and it will come easier as time goes on. And I'll see you in the next one.